Hello and welcome back to the next part in my God tier landscapes tutorial series on Houdini YouTube. So in the last part, we had a look at how do we create terrain macro textures from satellite data and aerial photography. And you can see that I have gone ahead and I created a whole load using the same technique that I outlined in that last video. So I'm in a position now to go into my scene in Unreal and start applying those textures again instead of the kind of detailed textures. But I want to do something before I do that. I actually want to go in and have a little look back at the how do we kind of set up the biomes inside of Unreal, because up until this point, we've kind of just been going through like step by step the hows, like the technical process of getting Houdini data, satellite data into Unreal. And now we're kind of getting to a turning point in the series where we're starting to think, okay, how do we actually get it to look good? And how do we get it to look like reference? So I'm going to quickly load up the scene as it looks now. So this is actually the scene that I've been working on in my spare time. So I say spare time. This is what's been taking up the majority of my time since the last video. And you can see that I've put a lot of work in here to improving the kind of blending of the terrain textures and making it look a whole lot more realistic. Now, I'm not done. I haven't added detailed textures in. I haven't started set dressing. And in fact, I'm not even done with the biome distribution because making kind of high quality work that you're happy with takes a lot of time. But I am at the point where I think we're ready to kind of discuss this process in the next video, which is this video. And you can see the state that we left it in previously. It doesn't look nearly as good. So this is how it was at the prior to the macro textures in the last video. So we haven't actually added them to the terrain yet. And you can see this is just looking a little bit rough overall. But the point here wasn't to make the terrain look good up until now. The point was just to get that technical process in and kind of working. So how did I take the terrain from this kind of result here that we're looking at to the result that I just showed you previously, if I just switch over here to this new result. Now, this is just as performant as it was before. It does have a few more layers on the terrain, but it's pretty lightweight. And I've actually gone ahead and taken out the detailed textures for the time being, and I've just completely removed all the grass, and I've just been readdressing the biomes. And this is because I don't really want to have anything clouding my judgment. I want each individual step of the process to be like focusing on what I'm actually working on. So if I'd left the grass applied to the terrain, if I'd left the detailed textures, that would probably cloud my judgment in terms of how the terrain looks in a macro sense. And really, you need to start from those bigger building blocks and kind of work your way into the details. Otherwise, you can get totally lost in the details. And before we actually dive into the specifics and the technicalities of how I generated these splat maps, I'm just going to show you kind of my process for like kind of starting to think about how do we actually bring this to a more realistic end result like you see for you. And the key kind of crucial ingredient of that is, of course, reference. So reference is hugely important. And I just went online. I started looking at photos of the Lake District. And I found some really nice kind of like images here. Lots of purple heather, which looks really nice. Kind of that like reddish appearance that we see. And here I really like this reference, even though it's kind of been tampered with in terms of the color a little bit, because it shows you kind of like all of these different elements of the terrain. You can see like we've got these fields down in the valleys. We've got a gradation up the slopes to like these rocky hills, these patches of heather and dead ferns. And it's really nice, a really nice mix. But what I found when I was looking at all these references, it's kind of hard to like settle on one that you want to aim towards. And the reason for that is because they're all different locations, but actually more importantly, there isn't much information about which season we're looking at. So I realized I needed to kind of establish what kind of season I was going to be aiming towards. And I very, very luckily actually stumbled across a wonderful photographer called Andrew, who goes through different parts of the UK, parts of England, and just takes an absolute ton of photos throughout all the seasons. And he's an amazing photographer. So I was really lucky. It's not often that you find this kind of resource. But he actually has photos of the specific area that I'm looking at throughout all of the seasons. So this is an absolute treasure trove if you're kind of working as a landscape or an environment artist to find this kind of amazing resource. The only thing that could be better than this is if you went to the site yourself, and even then you're not going to have the kind of documentation through the seasons. So I'm looking at Buttermere, the area, the lake that I've kind of focused my terrain around, and this is in, I think this is probably September or October time. And I actually just went through his entire library of photos. You can just see how many he's got. I didn't make it through all of them, but I went through an awful lot of them. And I basically brought those over into this great program called PureRef. So you can see that down here, this section here is kind of like my unguided, like kind of just going out fishing, seeing what I can find. But once I stumbled across Andrew's work, I actually went and was a little bit more ordered and methodical in how I approached it. And I pilfered photos across all the seasons. This is probably too many. You probably don't need this much, but I love looking at beautiful landscape photography, so I really enjoyed this process. And if we just go over to January here, we can start to have a look at this environment throughout the seasons. You get to see a real rich tapestry of colors and weather scenarios as it's changing. But this really characteristic kind of like heath, like brown and dark dead heath here that we see through like the early part of the year into spring. And then once we get to spring, so around April, May time, you get this beautiful flowering. Everything becomes much more lush and vibrant and green. And it kind of continues that way through summer. You still get these like beautiful patches of color on the hills until you kind of end up around like September, and we start approaching autumn. And I'm just going to whiz through here very quickly, look at some more of these, because just some of these photos are just absolutely stunning. What a photographer. I highly recommend you go and check out his work. Give him a follow on Twitter. And I'll just kind of keep whizzing through until we get into winter here. So you can see just the beautiful change through the landscape until we see these beautiful kind of snowy, foggy ones in the end here. But I have a drive. I wanted to make all of these seasons. If I had the time, I would do all of them. I'd make the landscape kind of like dynamically change with the seasons. So I think that might be like a whole nother tutorial series. So maybe we'll get to that in the future. But in the end, I actually decided I wanted to go for like September, October time. So kind of like just end of summer, start of autumn, because I really liked how those references looked, how you get such a rich variation in between, like contrast between the greens and the browns of like, there's still things that are flowering for the first time, but there's also the decay, of those things from spring that started to die. So I kind of settled on this look. It's become my Bible. So I've come in here and study it very closely. And I just started to pick out the elements that I wanted to replicate in my terrain. So you can see we've got this very lush kind of green that we see at the valley bottom here. This is probably a better example with like lovely hedgerows. So I'll be looking to kind of emulate that, although I haven't really gotten onto the valley bottom yet. But the area I've been focusing on mainly so far is these kind of like slopes with the beautiful dark heather mingling into the sort of the dying bracken. Bracken is ferns, basically, specific kind of ferns you find in this sort of environments. And you just get this very sort of almost alien landscape with this like reds that you don't typically see. At least you don't see very often in video games. So this was something I thought would give the landscape a really unique look. And I love this one here with the bench looking out there. So, okay, we've kind of like ogled at these photos quite a lot. We've kind of gone, wow, well, isn't this beautiful? Like we've picked out a few elements, but we need to be a little bit more granular. We need to be a little bit more analytical than that. So if I bring this back up again, I'm going to start picking out the things that we want to see, we want to replicate. So I've just got light shot installed. So I'm going to start just kind of drawing around here. So I wonder if you can actually see that. No, I need to switch to my desktop. There you go. So maybe now you can actually see see where I'm drawing. I hope so anyway. So I want to pick out this kind of this thing here. No, you know what? You can't see where I'm drawing there, very frustratingly. So we're not going to mind about that. But I just kind of follow my mouse. And you can see we've got these like patches of I think this is the dead ferns here, and it's very splotchy in its appearance. And then it goes up to like more kind of like continuous, more homogeneous on the steeper slopes. And we also notice in this reference that you have a very directional kind of effect, where on some slope you have none, and then there's the natural boundary of the river, and you have a lot on the other side. So this is going to be something we're going to be looking to kind of like capture in our environment. And we also have the gravel. You can see that gravel there. So we're going to want to recreate that, where it's sort of following along the river's path there. Not perfectly, because it's sort of like the gravel will have been carried down in flood waters, and when the river changes its course slightly, it will have deposited gravel around. So we're going to be looking to create that kind of messy gravel, as well as representing, if you can see that little path running alongside there. Now, our LIDAR data has all of that beautiful information about where the paths are. So we're just going to be looking to try and pick it out by filtering the terrain and applying different masks to it. I'm going to go over here, and again, we notice a very directional kind of shift. On one side, we have this lovely, beautiful green grass with a few rocks scattered around it. And then on the other side, it's much more like eroded, much more gravel, much more rock exposed. So you can see that the weathering and the exposure has changed the appearance of the landscape according to what kind of direction it's facing. So we're going to be looking to capture that with the way that we kind of like do our rock and gravel and grass. And we're also going to be looking at where that gravel and rock is placed. So you can see the rocks is sort of really on those protruding bits of ground where it's most exposed. And then the gravel as well. The gravel as well is on those kinds of protruding areas, although slightly less, like protruding than, say, for example, the rocks. And we also notice that we see like how the gravel has slipped down in the crevices a little bit there. It's a little hard to see, but if we find more references, it becomes quite apparent that that's what's happening. So yeah, we can see here again, that's quite a good example of how that gravel is sliding down between the crevices there. You have the rock on the most exposed and steep parts, and then you have heather kind of like in the gaps where the gravel hasn't pushed it away and where it's not too exposed that it just gets kind of weathered away down to the raw stone underneath. Okay, so that's a lot. That's a lot of things to consider. And it can seem a little bit daunting. I know I was daunted when I was trying to consider how I was going to create all of these effects. And I considered all sorts of options. I considered just using kind of the satellite images and filtering them in Photoshop and trying to extract masks based on color. I tried that and, it didn't really work too well. It was a little bit noisy, a little bit unpredictable. And I realized I didn't really want to create like an exact copy as down to a certain level of like this environment. I wanted to sort of create a Lake District inspired landscape. So I needed to come up with a way of generating those kinds of masks, those layers myself. It is still doing it myself or yourself. If you use Photoshop, you can absolutely do it that way. Hell, you can even go online and find all sorts of amazing resources like kind of crop data, land cover data that people from like the UK Geological Society have already surveyed. And that's like a totally valid way of doing it, especially if you want to create like a digital twin of the landscape. But it's not what I wanted to do, so I didn't go down that route. I wanted to try and analyze sort of the general patterns of the distribution, and then try to kind of create like procedural masks based off of the real terrain myself in Houdini. So, with no further ado, I'm going to show you what that process looked like and why it's been taking me so long. So if I just switch over to here, you can see this is the kind of the new Houdini scene that I've been working on. And I've kind of colored the terrain according to some of the masks here. We'll be going over how you do that. And you can kind of see, this is basically what I'm carrying over into Unreal, although I'm obviously spending a lot more time on the colors and the texturing inside of Unreal so that it all blends together nicely. But in here, this is just a nice way to visualize all the masks you've created together. And you can see that sort of rich brown color is the sort of heather. It's got a kind of splotchy appearance. I tried quite hard to replicate the sort of like this idea of like, okay, you have big bodies of heather and trying to mimic where they appear on the slopes, but also having like kind of like new, like pioneering heather or ferns that have kind of like creating little splotchy appearance where it's starting to grow into new areas or where it's starting to be eroded away. And also, I think it's worth pointing out that I've used different masks to influence each other. So the gravel cuts through the heather in places, and the heather will never grow like on where the rock is. And actually, it also uses information about the topology. So even if I haven't used a certain like kind of mask to determine that, like, say, sediment should go on a path, here's an example. I noticed that there was this kind of data, these areas where maybe animal trails exist. So I found a way to create masks based on the terrain that would also kind of suggest that maybe animals have been cutting through here often. And the really nice thing is that although this is all procedural, driven by kind of masking inside of Houdini, it's all based on the LIDAR data. So you end up with these really, really detailed, granular kind of information that you would take a long time to add if you were starting from like a completely procedural landscape. So you can see I've done the heather. I've tried to study the appearance of that scree pretty closely. I got some feedback from some friends and some colleagues while I've been doing this to try and push it closer. And there's still a bit more work to be done. But I think for a kind of a second pass, this is a good place for it to be in. You get to see how the gravel has kind of slipped down between the like crevices, but also is on these more exposed areas up at the top here. and you end up with these kind of like a mix between like thin kind of streams of gravel that have gone down the steep crevices, and then the bigger kind of body scree slopes that we can see in that reference. So if I just have a little fly around here, we can find examples that look quite similar. Maybe back in January or February, where there's slightly less heather on the hillsides, and you can see there's big bodies of gravel up there, and it's not just those kind of like thin streams that you get. Here you go. This is kind of the kind of reference that I was studying when I was trying to mimic how that gravel appears there. So that was how I approached the kind of like the gravel, and then we've also got these rocky areas, and quite often what you'll see is people will use like a landscape auto material that will like detect the angle of the ground and then apply rock where the angle is over a certain steepness. And there's nothing wrong with doing it that way, but it's a slightly kind of simplistic approach. And really, you'll notice if we kind of have a hop back into that pure ref again, and have a little look at the way the rock's distributed. Yes, for sure, you can see how it is influenced by the slope angle, but there's also other factors that influence, like the amount of weathering, where you see that. Let's look in here. That there are patches of like rock exposed where there's like maybe there's like small peaks which would be more eroded than the surrounding areas. So we're trying to consider all of these different elements to create like distribution maps that are a little bit more subtle, a little bit more granular, and a little bit more thought through than just doing a simple slope-based mask. So this is what's been taking all the time between this and the last video, as I've been trying really, really hard to study the reference and to kind of like mimic that appearance. And if we jump over into Unreal one more time and have a little look, I would love to hear how you think I'm doing. I still think there's a bit of work to be done to really kind of like bring it across the line in terms of like realism before I start worrying about things like detailed textures and scattering that grass again. But yeah, I'm getting pretty happy with the direction it's going in. So that's been like an absolutely massive preamble, and I hope that you found some value in it. Sort of trying to discuss my thought process as I like go into thinking about generating these masks before we actually get into the technicalities. And I have to kind of preface this by saying that there's not really like one right answer when it comes to generating the mask. And there's also not a make perfect masks button. This is probably what I would consider to be the most difficult and time consuming part of the process that requires a lot of iteration, a lot of looking at reference, and a lot of feedback from friends and colleagues. So if you're lucky enough to have people around you who provide honest criticism, this is the time that you want to be leaning on them. Okay, so just to kind of like re-emphasize how much work it really was, I'm going to jump back over into my Houdini demo scene. I'm going to show you the absolute chaos of my graph here. So up here, this is where we left the landscape. I don't know why that's happening. Sometimes when I'm working with terrains, it just starts to glitch out a little bit there. There we go. So this is where we left our Heightfield, like the playable area, and then you can see this is the actual layers that I've kind of settled on in the end. I can click through those and you can have a look at them individually. That's the heath mask. That's the rock mask there. That's the gravel mask. But I only arrived at these after an awful lot of experimentation, exploration, and kind of testing things out. And these aren't single nodes either. These are actually inside of them. They're subnetworks with quite a lot going on. So that's what we're going to be looking at today. Is we're going to be looking at how what I kind of arrived at for generating the masks. And we're going to be discussing some things that I've kind of taken away from that and learned, and probably trying to talk about some best practices, some of the most useful nodes. And we won't be doing it exactly the way I did it before, but we're going to be kind of approximating the same result. And hopefully there will be some value in that for you guys. Okay, so to begin with, I would suggest that if you haven't already, go and find some reference of your own. Go and have a look through, pick out some details, do some sketches, doodle around the areas and the things you want to recreate, because you're probably not working on the exact same landscape that I'm working on. And I would say a good number of layers to aim for to start with is probably 5 or 6. And the reason it's 5 or 6 is because that's enough that you can get some of the real kind of like variation and visual interest that you'll be seeing in the real landscape there. But it's not so many that you just get lost and overwhelmed. And you can always add more later, and I certainly will be adding more. So once you've done that, once you've analyzed your reference, that's the time when we need to go back and have a look at our Houdini scene. So I'm going to go back into Houdini. So this is the state at which we left Houdini before. You can see if I zoom out, it's nowhere near as messy as that new kind of prototype scene that I've been developing. And if I go over here to the Mask By Feature, you can see that we're just doing some very kind of like naive, kind of simple masking. It's only really relying on one node. And we're just trying to get to a quick result. And it's still, it looks interesting, but it's quite basic. It's quite, there wasn't too much thought put into it. And that's what I really was trying to address. And that's what we'll be trying to address in this video. You can see that I also haven't actually named the layers. They're just being output as layer 1, layer 2, layer 3. So we're going to be a little bit more deliberate. We're going to put a little bit more thought into it. And we're going to also try and work a little bit smarter about how we kind of like get all of these things from Unreal to Houdini to Unreal. So to begin with, I'm going to sort of make a list of all the layers that I'm going to be wanting to create to begin with. So we know that we want to have at least one grass layer, probably more. On my landscape, I'm using 3 at the moment, but we'll just kind of have a base layer of grass to begin with. And we're also going to be wanting to have some rock, some exposed rock. We're going to be wanting to have some gravel, probably some kind of dirt or sediment. And what else are we going to be wanting? Rock, grass, gravel, sediment, dirt. And let's just go with heath/ferns for the time being. Those will actually be, it'd be nice to break those into 2 layers, but for the time being, we're just going to treat that as one. So this is enough for the time being. You notice that I haven't put down things like woodland or bushes or all of that. That can come later. We're just really worrying about how do we kind of like basically texture our landscape, create like a nice second pass for the texturing. So the first one I'm going to worry about, we're not going to worry about the grass because that's pretty much going to be just a fill layer that goes everywhere. We're going to be worrying to begin with, let's have a little look at the rock layer. Now, the reason that I'm settling on the rock layer is probably because it's one of the simpler ones. And we're just going to have a little look up here. We're actually just going to, I don't know, I'm going to go ahead and just straight up delete these. I don't want them anymore. They're outdated, old hat. We don't want this flow field. And I'm going to change this to name terrain without capitals, terrain layer rock, like so. Now, let's click on that terrain layer rock, and you'll notice that in the file name path here, it's got $os.png, and that $os there, just a reminder, that means it's going to use the name of the node itself when we export the file to disk. So that just means that we have a little bit more visibility inside of the node graph about what each layer is, without having to go in and check the file name there. And all the other settings are fine. We don't need to modify these because they are based on the same settings that we haven't changed the resolution or size of our landscape. So we already set this up correctly before. Now, before I go any further, I don't want to have to go, you see where this is a save to disk button where you can export each individual layer. I could just do that every time I modify one layer, but remember, it's an iterative process, and we're going to be wanting to take these layers from Houdini to Unreal, and we're going to be wanting to do that more than once. So I don't want to have to go through and remember to manually click each terrain, like each output, like we're going to have 5 of them, remember, 1, 2, 3, 4, 5, and hit save to disk. I'm going to come up with a slightly more automated way of doing things. So I'm just going to right click down here in the graph and put down a null node. And what I'm going to do to this null node, so I'm going to grab this and the layer at the same time. I'm going to make them both red. So I'm just color coding them red so that I know that they're outputs. And then I'm going to select the null node. I'm going to go click this little settings wheel up here, and I'm going to go to edit parameter interface. And that's going to create a pop-up. So if I just go over here, you can see we've got this popped up window now. And I'm going to select the terrain layer rock again, and I'm going to drag that save to disk over into here. And that's fine. I'm going to hit OK. That's not working. I wonder why. Problems while creating some requested parameters. Node is outside subnet. OK, well, that's fine. So what I'm going to do instead is I'm just going to make a button. I'm going to drag a button in here. I'm going to call this button export all, like so. And once we've done that, we're going to go into the channels tab. And now we're going to drag that save to disk in and drop parameters here to add new links. There you go. And then we're going to hit apply and accept. And that now means we have an export all button on this null node. And when we press it, it's going to export the files from this node. Now, what's the point of doing that when we can just hit save to disk? Well, the point is now if we copy this layer, it's going to keep that reference as well. So we can call this one terrain layer gravel. We can call this one terrain layer heather. And we can call this one terrain layer sediment. And now we can just go in here and hit export all of these files are going to get exported to disk, and they're going to pick up the names of the nodes themselves. So we've just worked a bit smarter rather than harder there, and this will pay off. It only saves you a few seconds, but when you have lots of these layers and you maybe lose them, like maybe you've got one that's just like, if I just switch back to the other version of the file, you've just got this huge spider web, this huge chaos. I might lose track of where these actually are. I shouldn't, because I should be working in an organized way, but this kind of prevents that. And I'm just going to call this null export all layers, like so. So we've kind of prepped ourselves a little bit there. Now let's start thinking about how do we actually kind of generate like a rock mask. Now, I did mention previously something about masking by slope angle, and that's how I did it before. So let's just go and change the preview to this, and let's see what that would look like. So I've got the mask by feature, and by default, it's going to be creating a mask between 20 and 70 degrees. Now that's why this whole kind of like slopey area has gone bright red, but we only want it to kind of be the steeper areas. So there you go, 50, 70, and there you go. You're getting something already. You're getting like little kind of bits of rock, but it's a very, very sharp mask. It's also not really the best representation of where rock actually would get distributed. It's like one part of that, but it doesn't really notice anything like the kind of, I suppose, how do I put this? Like those kind of protruding areas. And we also don't really just end up with like areas where the rock might slightly be exposed, but not completely exposed, which you kind of notice when we look in the references. And you could kind of tweak this and pull these sliders around, and you'll notice there that just like froze up for a second. And this is a very important point to bring up. When you're working with Heightfield layers, you don't want to be auto-updating like when you drag the slider like that in the viewport. It's going to be very, very slow. We actually want to go and change it. So we go down to the bottom right down here. We change the update mode to on mouse up. So that means I can drag this around as much as I like, and it's not going to do anything until I actually release it. There we go. So what I'm doing is I'm basically creating a more gradual fall off here from the steep slopes to like the kind of like less steep slopes, I suppose. But there's also a couple of handy features inside of Houdini that makes working with these curves a bit easier. You notice how the profile currently is very sharp and requires 4 dots, 4 points. We can actually go over here on the settings tab and we can change it to hill. And you're going to see there that we get now a nice smooth gradation between those values. You could choose between valley, which is going to do the opposite there, or just go to smooth or sharp. And this can save you a lot of time if you get into the habit of working with those there. So if I go back to smooth, you can see that's now starting to pick out more areas. But what we're ending up with is these kind of like, sort of just like faint, smooth rocky bits. So I definitely think that this masking by angle is going to be a part of the answer. And I'm going to leave that in there. But I'm going to do something else as well, which I think is going to make this look a whole bundle more realistic. So this is a point where I'm going to introduce you guys to a new node. But before I do, we're going to put down another Heightfield Mask by Feature, like so. And then we're going to plug that in here to the output of the terrain there. And we don't want to mask by slope. We actually just want to mask the entire terrain. So you can see that if I turn off masking at all of these like toggles and hit invert, it's now going to mask the entire terrain. And I'm going to introduce you to what I think is the single most important node when it comes to texturing terrains inside of Houdini. And that is the Heightfield Slump node. So what the Slump node is going to do is it's going to kind of like it's going to like affect the masked areas of the terrain with gravity and try to sort of like, kind of like roll them down the terrain slightly. So I'll show you what that looks like. So with the default settings, we end up with this kind of like flow map. And this is really nice. So what you can see is that the steeper or more convex areas of the terrain have had the kind of like sediment roll off of them. Now, I'm trying to pick out the rocks specifically, and you can see it has picked out all of these rocky areas, but it's also picking out these kinds of like areas here where, to be honest, I would expect there to not be rock. It doesn't really look like rock in the LIDAR data. It looks like maybe grass or gravel because it's a bit smoother. So what I can do is I can actually go and adjust the repose angle here. Now this is going to mean that it's not going to slide down beyond like a certain angle. And if I put it on a value of say 35, we're now getting something really interesting. And notice how this looks kind of similar to the mask by feature where we did the slope mask, but it's kind of inverted. So let's just invert that and see what it looks like. What we're going to do is we're going to go to put down a node called HF Remap. I just searched Heightfield Remap, and I'm going to change the output to that. We're going to make sure that the layer we're remapping is the mask layer, and then we're going to change the output min and max around from 0 to 1 and 1 to 0. And look what we've got here. So this is really interesting. And it's kind of similar to the slope mask in that it's picking out a lot of the same areas, but it's also picking out other details. Like, let's have a little look up here. You can see on the slope up here, we're getting these kinds of like patches. And let's go and have a little look over here. It's picking out sort of the slopes, but it's also picking out these kind of like lumpy areas. So what's this about? Let's go and play with the slump a little bit more now. Let's try changing the number of iterations, for example. Let's put it down to 20. Okay, so the less iterations doesn't change it too much. And we're kind of getting these like rivulets down here too. So what happens if we just bring this value up, repose angle to 40 or even 50? Okay. So I'm starting to really like this. I'm gonna pull the spread iterations back up, and I'm gonna bring the repose angle back down to 45. And I'm actually gonna change the spread iterations again. I'm gonna make it lower. Okay, I kind of like how it looks lower. We get this kind of like sparse, patchy appearance, which is working for me. And I'm just gonna try to lower this again. And yeah, basically you're just gonna keep playing with that until I feel like I've got quite an interesting mask for use with the rock specifically. And I think something like that's gonna work. What I like about that compared to the slope is that it's a little bit more subtle. It's a little bit less like predictable. This is very regimented, you know, this slope. It's like, if this slope is over a certain angle, we're going to make it rock. Whereas the slump kind of does a lot of the same things, but it looks a lot more organic, and you get kind of like some more interesting areas where it's not necessarily just like the slope that's contributing to that, because it's taking into account other surface properties than just slope angle. I also like the fact that we're getting like these kind of splotchy areas on the slopes, which are more faint. So we're going to get a little bit of rock peeking through in those places. All right, so that's pretty happy with that. But I am going to introduce that mask by slope as well, just so that we get kind of like something slightly more, you know, complex again. So I'm going to put down a node called HF Layer, and I'm going to plug this in. I'll plug this in here. I'm going to select the HF layer. So I plugged the output of the remap from the slump into the leftmost pin, and I output the slope mask into that middle pin. And by default, it's just going to replace with the second input. But what we can do is we can tell it to only take the mask layer. And then what we can do is do a maximum operation. So it's going to add those two together. And that's now starting to feel like a lot nicer. To me, that's kind of like got a nice organic appearance. It's rich and it's varied. We've got the slope angle kind of masking, but we've also got more than that. It's kind of like textured, rocky appearance. So, okay, I'm going to take that output. I'm going to plug it in here. And before I start turning this like node graph into an absolute spider's web of nodes, I'm just going to right click and put down another null. And I'm going to feed the output of the final Heightfield into that null. And then I'm going to plug that null in to those masking. So it's going to take a moment to cook because we're changing the input on those masking. And what that means is we now just have one connector going to the rock layer masking, and we can kind of grab all of these nodes and go action, collapse the subnet. It's going to take a moment to cook again. And now we can make that kind of rock, we can name that subnet rock layer. And that, in that way, we keep all of the operations that are related to making that rock layer inside of its own subnetwork. Okay, so I'm going to save the project there. Make sure that you remember to frequently save your project. And now we're going to have a look at creating the gravel layer. So first off, I'm just going to hop back into my, my example scene, and we're just going to have a little look here and see what we were doing previously. So, all right, a little bit hard to break down because we're just looking at the end result. So let's just have a look inside this graph, and we can see that there's a Heightfield layer here, which is maximum, finding the maximum of the layers. So let's just follow that up to the left here. And we can see that one of the contributing elements to this mask is these kinds of scree slopes that we've got And I'm using slumping here, and I'm also doing a mask by feature. So I think I'm finding a mask on basically a lower res version of the terrain. So I resampled the terrain to 1/10 of its resolution, found the slopes of a certain kind of angle, did a very preliminary slump there on the low res terrain, merged that back into the high res data. So we've got the low res mask on the high resolution terrain, and then performed 2 slumps. So one small slump like that, which kind of made that mask pick up a lot of those high frequency details, and then another slump with way more iterations, but also a higher repose angle. And that's giving us a really nice appearance for the scree slopes. Now let's go back to that Heightfield layer. And we can see that it's not just that. We could walk up the node on the other side this time. Okay, so we're seeing 2 different elements here. I'm going to go first off to this leftmost path. We can see, all right, so this slump here is basically kind of like depositing a bit of gravel below the rocks. So it's very similar to our rock mask, but then it's just kind of been like dropped down. So kind of simulating a little bit of rock fall directly beneath the rocks. And so if we're going to have a look at the mask feature, we can see that this is being a mask that's being created in a similar manner to the rock mask. And then we're just doing an additional slumping step. So yeah, with a repose angle of 45 degrees there. So that's just basically dropping all the sheer cliffs. So that's kind of simulating a bit of rock fall. And then if we go back to that layer again and walk up the final path, we can see that we've also got this thing called eroded rich gravel. So that one is basically just picking out the very, very top of the hills on one side. So, okay, we're going to try and see, we're kind of emulating how there's more exposure on one side of the hills at the topmost points there. So if we have a look at the mask by feature, it will be combining a mask by direction, a mask by height, mask by slope, and in fact, it's even using a mask by occlusion as well. So we haven't looked into any of those yet. So there's quite a lot going on in that eroded hilltop section. I'll explain it in a little bit more detail as we rebuild it again. And then the kind of naive mask, the mask is very, very sharp, very sort of like just basically analyzing the terrain without doing any kind of simulation, but we just do a little slump that kind of embeds it more in, softens the edges, and gives it a nicer appearance. So let's set about creating that. So we're going to jump back into the working file, and I'm going to go over here. And this time, we're actually just going to put down a subnetwork straight away. So what we can do is we can just right-click and search subnet, pop it on that line there. It's going to immediately replace it, jump into place. And we're going to want to do 3 things here. So I'm just going to make a few comment boxes. I'm going to call this one scree slopes. I'm going to call this one rock fall. We're going to call this one eroded hilltops. And it's good practice to kind of bound your logic in these kind of separate components like this, because if you ever want to break one of these off and use it to generate a completely different layer for Unreal, it's pretty simple to do so. Let's leave that on there. And why not just have another quick little look at the reference board and kind of like take a quick look at some of those scree slopes, so we can see that those layers that I've kind of picked out are based in something. So we can see, okay, so there's maybe some scree slopes there in amongst the heather. And here you can see a really good example of those scree slopes on a steep hill. You can't really see any like rocks at the base of the, like rock fall at the base of those cliffy portions. So that's something I kind of just like imagined and maybe added in when in reality it shouldn't be there. So I'll reconsider that, but I kind of liked how it looked for now. And then finally, let's have a little look so we can get like a higher angle shot of the same area. Here we go. Yes, so you can see we've got those kind of eroded hilltops there too. And this is actually a really good point to mention that you don't just have to stick to using reference photo. You can also go to Google and sort of fly around the satellite data. That can be really helpful too. So yeah, let's jump back into the working file. Not that video. I'll just close you down. And where are you? There you are. And first thing I'm going to worry about is these kinds of scree slopes. So scree slopes, I know that I want them to kind of be roughly around the base of the hill, around here. So I can do like maybe a masking by height or a masking by slope. I think slope angle is going to be the way I'm going to go on this one. And that's going to actually pick up like this area up here too, if the slope angle is really shallow. So we're going to see how we kind of get on with that But the purpose of the slumping is that it will sort of pull anything down off the top as well and bring it all to the kind of base. So first of all, I'm going to do a Heightfield resample. I'm going to do it to a 10th of the resolution. So it's going to be 0.1 resolution scale. And the reason I'm doing that is because I don't want the Heightfield Mask by Slope to pick up. I'm just going to quickly put in a null here so I can preview the input as it comes in. Ooh. There we go. So I don't want the Heightfield slope mask to pick up all these small changes in slope angle. I only care about the kind of macro sense of the landscape. So I'm going to go in and do now that mask by feature. And I don't really want to get the whole slope. So I'm actually going to pull down the kind of max slope angle a bit because I only want to get like the kind of shallower, maybe the shallower portions of slope. But I, sort of play with this a little bit to the point where I feel it's kind of getting the areas that I'm interested in. So yeah, pretty much every slope now will have some kind of scree deposited on it. So I'm all right with that. You could kind of go into here, this little settings cogwheel, and change it to hill. It's going to give you like a softer appearance, which you could kind of tighten up by adding those points back in like there. We can come back and maybe play with this a bit later. I want it to be a little bit softer, like so. And then I'm going to do the very first slump. So I'm going to slump that down a little bit. Now, obviously, that slumped it all the way to the bottom of the terrain. That's not really what I'm going for. So I'm just going to reduce the spread iterations to 0. Just kind of pull it down a little bit. Few. Because that's that kind of like, you see how that mask by feature, even though this mask by slope is like content aware, when you do the slump, it just seems to really just like embed it into the landscape, like make it look like the mask is really part of the landscape there. Really, much more organic in its appearance. So I'm quite happy with that. I like that I've got like maybe some bigger splotches higher up and some small splotches around, some bigger splotches near the base of the slope. And the higher I pull this value, the more that's going to slump down to the valley floor. So there we go. Maybe I'll go with something like that for now. And this is the point at which I want to now bring that low resolution mask onto the actual high resolution terrain. So what I'm going to do is I'm going to right click and search for another Heightfield layer. And previously we were using this to combine 2 different masks, but in this case, we're just going to take the null. That's the high resolution landscape, the input. I'm going to have a look at that. There's nothing because it expects the second input. I'm going to make that second input, that slump there. And you can see, oh, what's happened here? Well, it's actually not giving us the high resolution landscape. It's just giving us the low resolution mask again. And that's because we just need to select the layer, make sure that it's only replacing the mask. And there we have the low resolution mask now applied to the high resolution terrain. I'm just going to expand this work area slightly. And now we're going to do the first of the higher resolution slumps. So we're going to slump that data again. And let's have a look what we get just kind of off that. All right, so that's kind of embedding the, that's kind of causing those like rivulets, to form. Let's just see if we can pull that down a little bit. I only want it to kind of like, you see how if we have none, we just have that low resolution mask, but even just a very small amount of spread iterations is going to make it look like it's kind of embedding itself into that landscape a little bit. And what I really like is that we still have that kind of soft fall off, but we also have that kind of like, that kind of awareness of the underlying terrain. So it creates a really interesting fall off between the areas of the scree and not scree. And now finally, I'm going to do one more slump. This time it's going to have like a repose angle. So that means the rocks are going to fall, but when they're on a slope of a certain angle, they're not going to slide down. So just to kind of better illustrate what happens, if we increase the spread iterations here, you see it's all that gravel is just sliding down the hill, like almost like water. There's no friction. And obviously that's not really that representative of what gravel would look like if it was doing this. With gravel, you'd probably expect that bits of rock would get caught and held even on a slope. So we're going to plug that into that new slump there. We're going to leave the spread iterations on 100. We're still going to get that watery behavior by default, but then we're going to go to the repose angle. We're going to set that to 45 degrees. And now you're going to see we get this really interesting result where it's kind of like building up in certain areas and less so in others. And we can just increase the number of iterations there so that it kind of runs the simulation until everything's in its final place. Not much change between 100 and 500 there. And I might just lower the repose angle so that it slides down a little more than it is currently. You see that quite small changes to the repose angle can have quite a pronounced effect on the end result. And I think, there you go, that's what I'm after. So you can see now that it's sort of spilling out into these kind of like nice, wide, kind of flared patterns. And we're still getting a smooth but interesting fall off. So I think that's kind of like a nice place for us to leave the scree slopes for the time being. And we're going to move on to thinking about the rock fall. So for the rock fall, we're very much just going to repeat what we did for the rocks themselves. So we're going to do a mask by feature. We're going to turn off the mask by slope. I'm going to turn on invert mask so that we mask everything. I'm going to do a Heightfield slump. I'm going to pick a repose angle of maybe 40-ish degrees. And then we're going to do a Heightfield remap. We're going to exchange the output min and the output max. And we need to make sure the layer to remap is mask, not height. That was my mistake there. And then we have a nice rock mask. And then we're actually just going to do another slump. So you can see that what I'm doing here is I'm basically just chaining together lots of like a few different nodes, kind of like using the same node but in different ways. And that's what gets us to that really nice kind of really nice end result, which looks more complex and more natural. And there we have. Now maybe the repose angle is a bit high, so I might just try putting it on 40. And you can see now we're kind of getting that slippage of the rock fall is what that's intended to represent. Where it's just let's try 50, where it's not on the slopes themselves, like the steepest parts of the slopes, but it's just below the steepest parts of the slopes. I think something between 40 and 50 is probably what we want. So I think I'm going to go with that. And now, if we put down another Heightfield layer node, we can combine our first slump with the scree slopes with our rockfall. And remember, we're going to have to change the settings on this Heightfield layer so that we're actually doing it only to the mask layer. And in this case, we don't want to replace it. We actually want to do the maximum operation. So this kind of adds them together. And now you see, this is really interesting because we get some really sharply defined areas of like gravel, which is where like the freshest rockfall is. We also get that kind of soft like gradation of like on the lower slopes where the gravel's maybe accumulated over a long time, had grass grow over it again, and then fallen again. So that's kind of creating a nice, interesting result there. Pretty happy with that. But the last thing I want to do is I just want to pick out those ridges which are extremely exposed to the elements. So what we're going to do here, first off, I'm going to go down to the bottom and I'm just going to make the actual mask itself the output. I'm going to remove these inputs I don't need and just kind of reorganize this slightly. And I'm just going to left click and then drag this over here and press Alt left click, and it creates a reroute pin. And I'm going to feed that in there. And I'm also going to feed that in there so that we can keep our graph slightly more organized. Okay. So now I'm going to expand this eroded hilltop section, and I'm going to create a HF mask by feature. And what I'm looking to do is I'm looking to pick out the tops of the hills on one side of a certain slope angle. So quite a lot of things are going to go on in this mask by feature node now. So at slope angle, yep, I do want to do something with this. I'm probably just going to put it on hill by default, so we get that nice smooth gradient as our starting point. And then we're going to go to mask by height. Now, if we do compute range here, it's going to automatically find the base and the top of our landscape. And you can see that this curve here is basically saying, pick the whole landscape apart from the very top and the very bottom. So again, I'm going to go to hill. It's going to give you 1 point I can move around. And I'm just going to minimize this curve and maximize the new curve. And do you see we've kind of got like a gradual fall off from the center of the landscape there? I'm just going to pull that up to the right. So it's going to basically try and pick out the top a little bit more, but not the very crest. And when you have multiple of these like slope, height, all working in the same mask by feature, the default behavior is for them to multiply together. So that's kind of giving me getting me in the direction that I want to be going in. I might just bring that even more up towards the top, so that it's in fact, you know what? I'm going to go for not a hill. I'm going to go for this linear. So I just have one kind of no, not linear, smooth. So I've got this kind of like gradual fall off from top to bottom. And then if I pull this up over here, that's going to tighten up that mask to the very top portion of the terrain. So, okay, I'm kind of liking that. I might make the top a little bit stronger by pulling this piece to the left. There you go. So that's kind of going to bring it down a little bit and kind of just move that around until it's kind of picking out the areas that I want it to pick out. And then I'm also going to go and mask by direction. And I'm going to kind of pick out the sides we want to pick out. So that's all right. Let's go and put that on hill 2. It's going to give us a more soft fall off. And we also want to increase the angle. So I'm going to increase the angle to 90 there. So you can imagine there's an arrow kind of pointing this way. And then the angle, 90 degrees, is going to kind of like find everything that's within this 90 degrees. And then that kind of like the shape of the curve means that it's going to be very strong masking in this direction down to a very small mask. I don't know if that illustration helped at all, but that's kind of how I visualize it. So then what I can do is I can kind of move that point to the left over there and drag up another point, and I can make that mask kind of more aggressive on just this side. And you know what? I want it to go around. I don't want it to be a very strict rule, so I'm going to kind of allow it to kind of come around the back like that a bit too. Now, this is all right already, but there's something else. There's another really powerful masking functionality that we're going to be using a lot more of in a bit, and that is this mask by occlusion. Now, what I'm going to do here is I'm actually going to just make another mask by features off to the side so we can just explore what that mask by occlusion does on its own for a second. And I would say the mask by occlusion is the second most useful terrain texturing feature after the slumping, or kind of on a par with the slumping. So when we turn on mask by occlusion by itself, you see we've got like an interesting mask which seems to become like whiter in the valleys and in the in these kind of crevice areas. And if we just pull this kind of like leftmost pin on the occlusion ramp all the way up to the right there, we're going to see something a little bit more stark. Okay, that's really interesting. So what's happening? Well, what the occlusion ramp is doing is it's kind of trying to like find the areas of convexity versus concavity. And we have a view distance we can set. So if we put this on a value of 10, you're going to see it's going to basically just like create this really, really nice textured mask, which is kind of like right now picking out all of the most like thin kind of like crevices, if that makes sense. And if we set the view distance even lower, it would find even smaller details. Now, if we do it the other way and increase the view distance, it's going to start not only finding the small crevices, but actually entire valleys as well. So you can see it's picking out the entire valleys there. And when you're working with the occlusion ramp mask, you might find it's not that responsive when you have the default curve profile. So if you have a curve profile like this, you might be like, okay, well, that's just almost entirely red. So it's not very useful. And what I found is really helpful here is if you just pull that kind of leftmost pin, you actually just work in like the last 20%, like that kind of portion of the graph all the way over there. And what we can do then is we can press these buttons. You see this button right here. It's going to actually invert the top and the bottom like so. So it's a really nice way to kind of play with that. And what we can also do, because this mask will prove to be really useful later if we use it in interesting ways. So right now you can see that we're kind of like picking out the peaks, like the peaks and the valleys. But what if we just want to get like the valley sides? Well, the way that we can do that is we can create the hill like so. So that's automatically finding the middle portion. But what we want to do now is we just want to compress that again into that kind of last 20% of the graph. We want to do the same over here. And you're going to see we get a really interesting result now, where the valleys have been kind of isolated out of the mask. The peaks have been isolated out of the mask. And what we're left with is just a portion of the slope. And if we increase the view distance up to 1,000, so that means kind of, I think it's 1 kilometer. It's going to be shooting a ray 1 kilometer to see if it hits anything. You're going to see that we can get really, really varied and interesting and different masks that, like, you know, just by moving this curve now a very small amount, we can kind of pick out different areas of that slope like, depending. It's a good way to think of this might be like how sheltered is it? And right now we're kind of picking out the areas that are somewhat sheltered, but not as sheltered as the center of the valley, and definitely way more sheltered than the peaks. So, okay, that was a really long side amble, but we're going to be using that a lot. And basically, we just want to like use that to kind of define our eroded hilltop shapes a little bit more. So I'm just going to pull this all the way over here like we just did in our example. And you're going to see straight away that's kind of really made a much more interesting mask. So we've now got this like only the exposed areas at the tops of the hills that are getting picked out. Now, right now that mask is really faint. It's not really strong enough for my liking. So what I can do is we can basically just tighten up all of these. We can expand the area that's getting masked. So I'm going to pull that to the left there, to the slope. And then I'm going to drag this up here. That's going to mean that a larger portion of the slope is going to be given a full strength mask. And I'm also going to pull that to the right, that height mask, so a bit to the left there. That's also going to kind of pull it up, make it a bit stronger. And that mask by direction is, I think that mask by direction is all right because it's doing its job right now, where it is masking by the direction. And finally, we have our mask by occlusion. And now I'm going to do that same old thing with the slump, which is this masking is great and all, but when we go ahead and slump it a little bit, it just looks 10 times better. And that's too much. I'm just going to slump it just enough that it starts to sort of pick up some of that interesting features of the slopes. I've decided I want the slope angle to actually be even closer to the crest of the hill. So I'm going to go back to my mask by feature, and that slope angle there, I'm going to change the min slope angle to 10 degrees, see what happens. Yeah, that's better. Let's go to 0 and pull it all the way up to the almost up to the top. Okay, cool. So I'm not completely happy with it. It's not perfect, but it's going to do for now. And I'm just going to make another Heightfield layer. I can just copy this one. And now let's have a look at that result. Interesting stuff. So we've got a lot of scree on this slope. We got a like scree up at the top as well. Got some scree here, rock pool. We got like small features being picked out. We've got the big slopes. Okay, so that's pretty good. It's not going to be perfect, but with a bit more iteration, I think we've got the right ingredients. Just by tweaking, a few of those parameters, we can drastically change that distribution for the gravel. So let's jump out. Let's call that gravel layer, like so. And we're at a point where now we've got 2 of our masks, and we kind of want to visualize what they look like together to kind of figure out, are they working together? Is that the kind of result we're after? So what we're going to do is now we're going to create a node called HF Visualize. And you're going to see that when we put that node down, it expects an input terrain. And then we also have these kind of layer inputs and a generic height ramp. So first of all, let's make sure that we're actually hooking our terrain in. So let's right click and search for an object merge. And we're going to, with that object merge selected, go up to the out final height field, and we're going to drag that into object 1. I'm going to color that green, just like the out final height field, so we know they're connected. And first off, we're going to put that into the visualize. Now, we see we get some color straight away, but only up to a certain point. And that's because we haven't calculated the range of the terrain height yet, the min and max elevation. So we're going to click compute range. Okay, so it's not bad. It's not bad. And we're just going to go and kind of set something basic up. I'm going to start with 2 colors. And I have a nice I'm going to flip them around. Have a nice dark green in the valley, and then a slightly kind of more yellowy green at the top of the hill, like so. Maybe even add one in the middle, slightly different green there. Let's go with that kind of bright green. It's a bit too luminous. Now, I'm not really too concerned with how this looks, but I do want to have like a rough approximation of the terrain. So I'm gonna lighten up the valley a bit, bring it into more sort of light green, like so. Maybe a bit more desaturated. Go, and then I'm gonna pull that kind of vibrant green down to the base of the slope, darken that up a little bit, darken that out a touch. And that's going to do me fine for the time being. Just want that dark green right at the kind of the base of the valley there. All right, so that's going to do me. And now we kind of want to, we want to bring in the layers we've created and then sort of apply a solid color via these layer fields here. The way we could do that, we make another object merge for each of the layers. So go up to the rock layer there, drag that rock layer in. And now we can do that same old kind of Heightfield layer approach. And we can layer in the mask. We don't want to replace everything, we just want to replace the mask. And we get the mask in, so we can now see that mask on the end result. But what if we want to visualize more than just one? Well, that's going to involve creating another object merge. I'm just kind of go through the process and show you the issue you might run into. This one's going to be connected to the gravel layer there. And now the problem is we've got two layers called mask and they're overwriting each other. And if we type in mask in here, it's clearly not going to, it's not going to find the rock and the gravel. It's just going to use one of them. So what we can do is we can go into let's first of all the rock layer, go for the output, and put down a node called HF copy layer. And the source layer is going to be the mask and the destination layer is going to be called rock, like so. And then we're going to do the same inside the gravel. And we're going to call that one gravel. And now, if we go to this Heightfield layer replace, we're going to go from the rock layer. We want to copy in rock. We go to the gravel layer. We're going to go to that Heightfield layer. We're going to copy in gravel. Now you're going to see we're going to lose both those masks. But if we go to the visualize, type in rock layer 9 and gravel layer 8, we now get those together on the terrain. And the default colors are actually fine for me right now. I'm not going to worry about them. So I'm kind of happy because I can see that the rock is picking out the areas that I think it should be, roughly speaking. Looks pretty nice. And the gravel, the scree especially, is pretty good approximation of what I want to go for. So we've got two of our layers, and that just leaves two more, the heather and the sediment. So next up, we're going to move on to the heather. All right, so we've done the rock and the gravel. Now we're going to do the terrain heather layer. So again, I'm going to right click, search for subnetwork. I'm going to drop that down straight away and call that layer heather. I'm going to jump inside of here and we're going to start thinking about how does the heather form. So at this point, could go and have a look back at the reference, but instead, I've already looked at it quite a lot and I'm going to let you go back and pause the video and have a look back at the reference if it interests you. So I'm instead going to have a jump into the other kind of prototype project I was working on. I'm going to find the heather layer. I'm going to have a little look in here. I'm going to walk down some of the, walk up. We're going to go in reverse. So we can see at the very end, we're doing a slight blurring. And we've done a remap here. I'm not sure what the remap is doing, but if we go to the store, we can see the remap is basically just sharpening up those boundaries a little bit. We've also got a Heightfield distort, so we haven't used that yet, but that basically allows us to add a little bit of noise to the edges of our mask. You can see it without and the with. It's very, very subtle here. And it's actually just more noticeable when you're looking at it in a macro sense. It kind of fuzzes it up slightly. And then we've got this Heightfield layer, but we're not doing a maximum or a replace. We're actually doing a subtract. So what that means is that this path off to the right is being subtracted from this path on the left. So let's worry about what's being subtracted in a minute. Let's just go and have a look up the path on the left that's kind of creating our base mask. Okay, so what we can see is we've got like kind of big solid portions. And then at the edges, in some places, you have this kind of cracked up splotchiness, which looks really nice. So that's what we're getting there. The remap is probably just strengthening the mask slightly. Yeah, that's what it looks to be doing, if anything. It might actually just be clamping. Yeah, so it's clamping. So we'll talk about that in a moment. We've got a slump as per usual. And we've got a replace here. So that means that we're bringing in the source height field and we're kind of bringing a mask in, probably from a lower resolution terrain. So let's go over to the right there. And yes, okay. So I've remembered what I was doing for the heather. And this is quite unusual. And I'm sort of abusing a couple of things here. So let's go up to this Heightfield layer, and let's just jump off to the left there for a second. And what do we see here? Well, we see a height field, but it's not our terrain height field. It's kind of like a custom height field. What is it? Well, if we go to my Heightfield Mask By Feature, we can see that this Mask By Feature is using Mask By Occlusion. So it's picking out the kind of occluded areas. And then what I'm doing is I'm actually copying that occlusion layer into the height. So it's going to be between 0 and 1 by default, because the mask is between 0 and 1. So it's going to be completely flat. And then I'm actually just scaling that up by 100. And that's what's giving us this kind of weird height field. Now, why on earth am I doing that? Well, the reason I'm doing that is because when we perform the Heightfield Slump, the Heightfield Slump depends upon the height of the terrain. It's always going to slump downhill. So I've done something a little bit creative here, which is I've basically told the slump node to use the occlusion mask, as the kind of like the influence, which means that instead of like sediment slumping downhill, the sediment is actually going to slump away or towards the most occluded areas. So in this case, the mask is finding the occluded areas. So what's going to happen, really bizarrely, is that it's kind of going to slump uphill. So it's kind of going to do the reverse, but not literally. It's going to be a little bit more involved than that. But it's basically going to kind of like gradually move away from the more occluded areas. Now, why have I done that? Well, my thinking there is that heather kind of is like an organic living organism, and it's going to kind of spread, and it's going to spread based on a few factors. And one of the main factors that's going to affect the spreading of the heather is the factor of like how much shade and moisture it receives. So I think that the occlusion is kind of a good like what's the word, like kind of occlusion is kind of like a nice shorthand way of describing how sheltered and how much moisture there is. So by basically slumping the heather away from the base, like from the most occluded areas, it's going to try and avoid the really, really moist and the really, really like sheltered areas, and kind of be on the slightly more exposed areas. But because the initial mask is at the bases of the hill here, like the base of the hill, the heather's going to kind of like sort of crawl up the hill. And that's kind of what we can kind of see if we go to this Heightfield layer here, where that layer is finally being added in. We have a little look before this like mask gets slumped uphill. So this is our last point where the terrain looks normal but low res. You can see that when I have a look at the resulting slump, it's kind of like tried to slump uphill, but in this really organic and interesting way. It's like crawling uphill, but trying to avoid the occluded areas. And I messed around for a really long time trying to find a way to create an interesting mask for the heather. And ultimately, I think this worked pretty well. Now, it took me, it was quite an involved, like weird way of doing things. But sometimes it can pay to get a little bit creative. And one of the things I especially like about doing it this way is that you end up with situations where the mask kind of like becomes aware of these small features that are like represented in the occlusion map, like these kind of like pathways and lines on the terrain, as well as like little kind of tiny peaks and stuff. So yeah, that's without, and then that's with the slumping. You can see it's kind of created those nice organic patterns. Then I do the remap. And then finally, we do that subtraction. And what the subtract is doing is, let's have a little look. It's basically subtracting this map. And this map is a combined map. It's got like all of the kind of like rivers and streams and flow map stuff. It's got the scree as well. You can see I've actually merged in the scree and just added that to this mask. So that gets subtracted from the heather too. I'm kind of assuming the gravel would like crush the heather, or the heather can't grow wherever the soil is really loose. And then we've also got that micro occlusion. So that micro occlusion is another useful kind of like way of abusing the occlusion ramp. It's picking out all of the like really most occluded tiny pockets. So that's like a nice way to kind of subtract some of those like features of the landscape, like lines and trails. And also I've used this Heightfield Flowfield. So the Flowfield is a node that's going to kind of like simulate rain on the terrain, and then kind of like how it flows down the terrain. And then I kind of like remap that so that it only picks out like all of the biggest channels And then I do a bit of noise on it to kind of distort those channels slightly like this, but quite a lot actually. And my thinking here was I was going to try and like add some kind of element of like animal trails. And my thinking was that the animals are going to kind of stick around near the water, but they're not going to walk right up the stream. So by distorting the flow maps of the channels like that, you kind of get this impression of like a path going up the stream areas, which I think might, you know, it's completely imaginary and procedural, but I think the illusion is kind of nice. It lends a nice quality to the end result, especially when you combine it back with the occlusion map and the gravel, and then you subtract that, and you notice that you can see a lot of those nice organic patterns being cut through, which gives the impression that there's like maybe animals that go that way. And in some other places, you have the water that runs down. So yeah, that's how I approached the heather. So I'm not actually, I think I'm not going to go through and recreate that just because it's quite involved, but I have explained that process in quite a lot of detail there. And we're also going to go and have a little look at the sediment layer now too. So if I jump inside of the dirt, you can see that we've basically got all of the rivers and some of the like kind of like the kind of maybe streams being picked out where the water's flowing down, as well as the kind of tops of the hills all over the place. And what would be really nice to add to this actually would be the beaches. You can see I've kind of had a stab at it here, but I could definitely do a bit more work on that to get the beaches to look good. So inside of the dirt subnetwork, we can see there's relatively few ingredients, but let's go back up a layer to the Heightfield layer here and follow it up to the left to begin with. So we can see this leftmost layer is very much just trying to pick out all of the like the water channels. And the way I've done that, so we go up to the top there, is I've done a mask by everything. So I'm getting out the whole thing, and then I'm doing the slumping, kind of like I did with the rocks, except this time I have way more iterations. So this slumping is basically finding all of the valley bottoms. So that's what I'm using that for. And then off to the right, I've done another slump. And what this one's doing is it has way less iterations. So it's still finding the valley bottoms, but we're not losing those kind of interesting like channels that are coming down. So we still got those channels kind of coming off of the hills. And this is kind of similar to what you get with the Flowfield node, but I just think that the slump gives us a more interesting and varied and organic looking result. So then I add those two together using the Heightfield layer with maximum. And finally, we replace that. So we put that back onto our terrain itself, Heightfield layer. I'm not actually sure that that was entirely necessary. Yeah, I'm not sure why that layer's there. I've forgotten. I think I could have just skipped it. And then we do a mask by feature. So this mask by feature, let's have a little look. It's using the mask by occlusion and the mask by slope. So let's have a little look inside of here. So the mask by slope is picking out, it's basically erasing anything which is over 40 degrees in steepness with a gradual phase. That means it's trying to find flatter things, but you see it's got a bit of leeway to still get some of those slopes. And then the mask by occlusion is just going to be picking out the kind of like small crevices. So it's going to like stop you see how we've got this slump kind of lends itself to these kind of big splodgy shapes. But this then mask by feature comes in and kind of like adds a bit more definition to those and like kind of makes it look a little bit more precise and organic. And then finally, we do another mask by feature, and it's another mask by occlusion. Another mask by occlusion. And this one is picking out even just the smaller channels within those areas. So kind of like a multi-stage approach to trying to refine that mask to the point where it only picks up the kind of the rivers and riverbanks and lake edge. We do one more slump. This slump kind of like, if we have a look before and after the slump, you see that some of these channels are quite faint. They don't have much like deposited in them. But then what the Heightfield slump is going to do is it's going to kind of like fill up those main channels a little bit more. So it's kind of doing a little, almost like a water simulation. That you could imagine that as being like a kind of like, oh, let's flow into the most natural places that water would flow to. So that's what I was trying to do with that side. And then on the other side, we go to the right. What this is the, it looks like we've got some of those kind of flow fields down the sides of the hill, but we've also got the top of the hills being picked out there and a kind of general dirtness, messy dirtness that's everywhere. We go on the right, let's have a look here. So this is the ridges that are being picked out here. And then I guess on the left, that's what's giving us this kind of noisy, dirty, kind of just general level of like, oh, let's have a bit of dirt everywhere, but especially in the crevices. And that's coming from specifically from a mask by feature, and another occlusion one with a very short distance and a slope as well. So between the angles of 20 and 40 degrees. So it's kind of like slightly like almost like a dirty ridge, kind of like we want to get like these little pockets of dirt everywhere. And that's kind of what, you know, I've done that with a few more layers, but that sort of brings us up to the point where we have a result that's going to look pretty similar to this, and is ready to take into Unreal. We've got all of the layers set up. So if you kind of go ahead and finish off those layers in your own time for the sediment and for the heather, and any other layers that you want to create as well, then in the next video, we're going to look at importing those into Unreal and setting them up with the macro textures. That was a long one. That's why I decided to not kind of show you everything in the end, like go through the whole process of setting it up again. But I pretty much shared all of the tips I can think of related to like trying to get nice, granular, interesting masks out of Houdini from LIDAR terrain. And what I'd add to that is that what you kind of really want to be looking for is like the boundary regions between your masks. Like how soft are they? How hard are they? How splotchy? And another thing to bear in mind is you really can add a lot of texture to your landscape by having like soft layers. So if we ever look back at that dirt layer in particular, you can see we do have the really well-defined portions, which kind of is just pure dirt. But actually, we've got a whole ton of areas that have just a little bit of dirt influencing them. And this is one of the major strengths of kind of going down the weight maps or splat maps approach versus like an auto landscape material, is that you have the ability to like really just add a huge amount of detail and variation across the whole landscape, and really give it this rich and textured and varied look. And these kinds of like faint layers that bleed into each other and across one another, that's what's going to allow you to create a really kind of rich and interesting, realistic, believable result inside of Unreal, when combined with those more kind of sharply defined areas too. So yeah, I would strongly encourage that you do set up this Heightfield Visualize as you're working. And that way you can kind of see how the layers are working together, even without their kind of proper colors or textures. And I'm really keen to hear how you get on and to get on to the next video where we will be importing this stuff to Unreal. Thanks so much for your time. If you enjoyed this content, despite its length, please like and subscribe. It's a real pleasure doing these videos and having the response that I've had so far. I'm really enjoying it. And thanks for your time.